Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Trigonometric Graphs, Question 8, y equals the cosecant of x. In order to order this complete Cram session, inbox me at memedicine@gmail.com. Be sure to spread the word and tell your friends and classmates about the availability of this Cram session also, okay? So let's delve into the problem. Sketch the graph of y is equivalent to the cosecant of x over the interval -2 pi is less than or equivalent to x is less than or equivalent to 2 pi. I'll give you a moment to think and formulate your solution to arrive at the correct sketching, and definitely press pause, okay? All right, so hopefully by now you've arrived at a solution, and if not, that's completely fine. Let's start this together. The easiest way to sketch y is equivalent to the cosecant of x is first to sketch y equals the sine of x. Okay, I'm going to show you why just now. We know that the sine of x is equivalent to y over r. Well, the cosecant of x is just the reciprocal of sine of x, which is r over y. And let's just orient ourselves a little bit, okay? When I say y, I mean the x coordinate. I mean the y coordinate, not x coordinate, sorry, of that it's going to be the y coordinate that the ray that intersects the origin, making the angle, stops at, okay? And then r is just going to be the absolute value of the measurement of a ray, because whenever we have a measurement of something, even if it's in a quadrant where it looks like it should be negative, it's a measurement, and you can only measure something that exists. So r is always going to be positive. So you just take the absolute value. But if y is, let's say, in quadrant 3 or 4, it can be negative, okay? So the negative contribution to any trigonometric function always comes from the y coordinate or the x coordinate whenever you're looking at it from the perspective of a triangle in a Cartesian coordinate plane, okay? All right, so that's just a little aside. We established that the cosecant of x is just the reciprocal of the sine of x, where sine of x is y over r, therefore cosecant of x is r over y, okay? And I also want you to recall that the domain of a function is the set of all possible values for the independent variable. And the independent variable on a Cartesian coordinate is usually referred to as x, okay? So here goes the x coordinate line, and because we're dealing with real numbers, and well, I'm going to tell you now that we're going to be dealing with real numbers. In the case of the sine of x, the domain is all real numbers, okay? But we're told in the question stem that we want to restrict this domain, or it can also be called an interval. We want to restrict it between -2 pi and 2 pi, okay? And what I also want you to recall is that the range is a set of all possible values for the dependent variable. And the dependent variable is usually expressed as y, okay? All right, so catch up. Well, I'm sure a lot of you don't need to catch up. You're like geniuses. But just take a moment to absorb the information given between this and all this, okay? All right, so the range of the function y is equivalent to the sine of x, okay, is going to be between -1 and 1. That's just knowledge that you should know offhand regarding the different features of the graph of y is equivalent to sine of x, or just the function y is equivalent to the sine of x, okay? All right, so here goes what this graph is going to look like when we finally establish it. But let's get into how we are going to use this to get to cosecant, okay? So at every point where y equals the sine of x is equivalent to 0, including the y-axis, we see that it's equivalent to 0 here. Because the cosecant of x is the reciprocal, so if you have a 0 in the numerator of sine, and then you're going to have a 0 in the denominator of the cosecant of x, this means that the cosecant of x is going to be undefined at every location where y equals sine of x is equivalent to 0, okay? And usually undefinition is visually represented as vertical asymptotes. We don't need to retrace for the y-axis. So here goes our locations of undefinition, if that's even a word. I'm just expressing it in that way for conceptual understanding, okay? And vertical asymptotes are usually written as dashed rather than solid lines, and we also have one that's hidden here within the y-axis, okay? Now, at every point where the sine of x, y equals the sine of x, is equivalent to 1, we also know that the cosecant of x is going to be equivalent to 1. Because if we have a 1 in the numerator and you know this implicit or invisible 1 in the denominator, and if you flip 1 over 1, you're still going to get 1. Okay? So we just established that wherever it's 1 for sine, the value of the cosecant of x is also going to be 1. And so it's logically you can conclude that at every point where the sine of x is equivalent to -1, okay, the cosecant of x graph is also going to be equivalent to -1 as well. Now that we've oriented ourselves in terms of establishing where sine of x is equal to 0, 1, and -1, we have enough information, believe it or not, to actually graph the cosecant function, because minus the areas of undefinition, the cosecant of x graph is going to intersect the sine graph at the points we just mentioned for 1 and -1, okay? So this is what it should look like. So here we have it, these concave up and concave down curves are the graph of y is equivalent to the cosecant of x. So we just completed the graph of y equals cosecant of x by drawing concave up as well as concave down curves between the vertical asymptotes, connecting where sine of x is equal to either 1 or -1, okay? And if you don't get that, just replay this in slow-mo. Go to the settings tab on the video in the lower right-hand corner, okay? So now what we want to do is completely erase the graph of y equals sine of x, as well as the vertical asymptote for a clean finish, okay? So you should have definitely done this in pencil. And there you have it. Y is equal to the cosecant of x. Now, I know we did this long drawn-out process, but you could have also used your graphing calculator to aid you in the drawing of y is equivalent to the cosecant of x, okay? So let's see how this is done. All right. Again, you can render this graph on your graphing calculator. It's just that, let's say you have to show it on paper, you would have to know exact location points on your Cartesian coordinate xy plane so that you can accurately give a drawing that looks scaled, okay, as opposed to not drawn to scale. So something I want to tell you regarding your graphing calculator, and the graphing calculator series I'll be referring to here is the TI-83 or TI-84 series, and even the newer versions, most of them have the same buttons, okay? I just want to give you a heads up for that for this type of calculator, as well as other brands, you know, RADIAN mode and ZoomTrig are the best graphing modes to be in for reciprocal trigonometric functions. So let's see how this is done. The first thing that you want to do to set up a proper graph is be sure that you're in radian mode rather, okay? And you do this by hitting mode. When you press mode on your TI calculator, the screen will come up or something that looks similar to this. Then the next thing you want to do is press the down arrow, because initially when you pull up the screen, the cursor will be flickering over normal. You're going to press your down arrow once more and it will be flickering over float. Now we see here that degree mode is selected. What we want to do in order to get to radian mode is to select the left arrow, okay? And although I'm going to show you hit enter here, you don't need to hit enter to lock in radian mode. All you need to hit are the next two buttons, second mode. And second mode combined is the function quit screen, and it takes you back to home screen. Okay? All right, so that didn't go so bad. The next thing that you're going to do now is input the cosecant of x function. And we do this by hitting the y equals button, you know, at the top of the calculator towards the left-hand side, and the screen will come up. And your cursor will automatically highlight the Y1 line. It'll be, you know, bold and black background. That means that this will show if you are to graph this function. Okay, so in order to input the secant of x, remember it's the reciprocal of sine. So most of these calculators don't have an actual cosecant button. So what you have to do is manually manipulate sine. So you're going to do 1 division sine, sine, and then sine comes preloaded with an open parentheses, and then you're going to hit your variable button, x t theta n. Usually it's set to x, so then an x variable should pop up, and then you're going to close out your parentheses, okay? And what you're going to do now to view this is press graph, all right? So by pressing graph, you're going to see the cosecant function, similar to what we had earlier. So what you want to do is, you know, just mimic this graph, find out where the minimums are for these concave up curves, find out where the maximums are for these concave down curves, and also find out where you have vertical asymptotes, okay? And let's see what's interesting about this. Yeah, like I think, I don't know, this might be about 90 degrees-ish, you have a vertical asymptote. Remember that the x coordinates, since we're in radian mode, they're measured in increments, I think, of 90 degrees, okay? So yeah, that's that. Let's see what else. Oh yeah, and make sure you're in ZoomTrig mode. You get there by pressing Zoom and the number 7, and then it'll automatically take you back to the graph screen. And 7 is the selection number for trigonometry mode, Zoom trigonometry, and this is how your graph should appear, okay? All right, so thanks for your time, and be sure to spread the words to your friends who might need to cram for Algebra 2 or just trigonometry in general, or just graphing calculator skills, okay? All right.